Okay, in this cast, we'll be looking at proportionality as well as common relationships in data. Okay, this forms the patterns that we see in science. Super important. Okay, so first is what we call direct proportionality. Okay, uh, you know, the definition is if we have some variable y over some variable x, if their ratio is equal to a constant, which we called the constant of proportionality. Okay, so if the ratio of some variable y to x is a constant, we say that y is directly proportional to x. Okay, symbolically we say y is proportional to, kind of a funny symbol, to x. Okay, so this is symbolically. Okay, and mathematically, direct proportionality looks like a linear equation that you might be familiar with, which is, so if you kind of put this into one line, we will have y is equal to k times x. Okay, so that kind of looks like mx plus b, right? Y is equal to k times x. Okay, so that's directly proportional to x. Okay, another type of proportionality that's super important is called inversely proportional to x. Okay, and the definition for this is if some variable x times y is equal to constant of proportionality, we say x and y are inversely proportional. So what might make more sense is that y would be equal to k over x, right? You might be used to 1 over x as an inverse function. Well, that's why we say that when y is equal to a constant over x, we say the two variables are inversely proportional. Okay, and so symbolically this is y is proportional to 1 over x. So we can say y is directly proportional to 1 over x, or y is inversely proportional to x. Something you just have to get used to. Okay, so once we know about these proportionalities, we can see them in data, okay, through these 4 common relationships that I'll explain right now. The first very basic one is a linear, and hopefully we've seen this already. Linear looks like a straight line, okay, and the idea is if y increases, then x will increase at the same rate. Okay, so that's why we have a constant slope. The steps are constant between each point. Okay, they increase at the same rate. So the equation for a linear line, the general equation is y is equal to mx. Okay, an example of this is circumference is equal to 2 pi r radius. Okay, so this would be our m, this would be our x variable, and this would be our y. Okay, the idea is, you can see in an example here, is if we double x, so if we double our radius, we would double our circumference. Okay, so that's what I mean when I say y increases at the same rate as x. Okay, because doubling x, okay, also doubles y. Okay, so what's something that different types of relationship is square. A square looks like a parabolic curve, so square relationship. Okay, and in this case, y increases at the rate of x squared. Okay, so the idea is here, the general equation is y is equal to mx squared. Okay, an example of this would be the relationship between area and radius. We know that area of a circle is equal to, pi r squared. So this would be x squared and r squared. M is the pi, and the y variable would be a. Okay, so that's a mathematical example. And the way we can visualize this is, for example, if I were to double x, so doubling x quadruples quadruples the y value. What do I mean by that? Well, look at over here. If we have a sphere, or right, if I have a radius 1, the area is, so the surface area, or a circle, is 3.14 meters squared. Okay, if we were to double the radius, okay, all of a sudden the surface area would be quadrupled, right? It's this times 4. Okay, so that's a square relationship. Doubling x has the effect of quadrupling y. It's confusing at first, but hopefully that will sink in after a little bit. Okay, and just we'll have more experience with these two last common relationships. They're inverse, which looks like that, and inverse square, which looks even more kind of closer to the axis. Okay, and here in this case, the general equation is y is equal to m over x, and inverse square is y is equal to m over x squared. Okay, so the effect here is, in this case, if we double x, you would actually half, oh my god, halves y. Okay, if we, in this case, inverse squared, if we increase x by 2, so if we double x, we would quarter y. So notice here x squared quadrupled because we're x squared on the top. In this case over here, it's x squared on the bottom. So if you double x, you have something over 2 times that. So squaring that is something over 4 times that. Okay, so it would quarter y. Again, this takes a little bit of time to get used to, and will help on your practice in class.